Have you ever tapped a button on an app and just wondered what happens next? In that split second? Well, it's not magic. There's this whole invisible world, an architecture, that makes everything work just right. So today, we're going to pull back the curtain and look at the blueprints that power our digital lives.
Okay, let's start with a bit of a high-stakes problem. Because in the world of software, sometimes your biggest success can actually trigger your biggest crisis. So picture it, your app, your baby just goes viral. Overnight, 1 million people sign up. That's the dream, right? But here's the real question. When that dream actually happens, what does your system do?
Yeah, that's what happens. It all just falls apart. The very success you were hoping for becomes the thing that breaks everything. Total chaos. The dream becomes a nightmare, just like that. And listen, this isn't just a hypothetical. That number, 1 million users, can be the very real breaking point for platforms that weren't built to grow. It's like building a beautiful house on a foundation of sand. It just can't handle the weight.
So, how in the world do you prevent that kind of collapse? Well, the answer is something called system design. Think of it as the architectural blueprint that makes sure your creation is ready to handle its own success.
To put it simply, system design is all about planning ahead. It's kind of like the difference between building a small shed in your backyard and building a skyscraper. For that skyscraper, you have to meticulously plan every single beam and every wire for immense scale. System design is the exact same idea, but for software.
So, what are we really trying to do with good system design? Well, there are a few key promises. It has to handle millions of users, process massive amounts of data, and, this is huge, it has to be both available and reliable. High availability just means it stays online, even if everyone is trying to use it during the Super Bowl. And reliability means it actually works correctly every single time. No glitches. These are the cornerstones.
Okay, so how is a system like this actually built? To understand that, let's meet the key players. You can think of them like a super efficient team where every member has a very specific job to do. First up, we've got the load balancer. I want you to picture a traffic cop at a super busy intersection. It stands right at the front gate, and it sees every single request coming in. Its only job is to direct all that traffic, making sure no single part of the system gets totally overwhelmed. It's your first line of defense.
Next, we have the two main workhorses. The server is the brain. It does all the thinking, all the processing. But to do its job, it needs information. And that's where the database, or the library, comes in. The database is the quiet, super organized partner that stores and hands over every single piece of data the brain needs.
All right, we've met the team. Now let's see them in action. We're going to follow the journey of one single request, from the moment you click all the way to the content popping up on your screen.
This all happens in the blink of an eye, but let's slow it way down. It's like a 4-step dance. Step 1, your request hits the load balancer, our traffic cop. Step 2, the load balancer points your request to a server that's free. Step 3, that server, the brain, asks the database, the library, for whatever info it needs. And finally, step 4, the server puts it all together and sends the complete response right back to you. That's system design in action.
The really crucial takeaway here is that none of this happens by accident. It's all about foresight. Great system design means building a strong foundation from day one, planning not just for the users you have right now, but for the millions you hope to have down the road.
It really all comes down to this. A brilliant idea, that's just the first step. Because without that strong architectural blueprint, success doesn't look like success, it looks like a total collapse. The design is what turns a cool idea into something that can actually last.
And that brings us to a really fascinating question. We know the load balancer is the traffic cop, but how does it decide? How does it pick which server gets the next request? Is it just random, or is there some kind of hidden strategy at play? We've talked about the what, but the how, well, that's where the real genius is.